No, people on chairs, they can see. Yeah, that would be good. Recording. Turn up. Oh, do you want to turn up the waiting security? And then just disable waiting.
What is it using for my? Check 1 2. Check 1 2. Check 1 2. Those in Zoom, if you hear me clearly, please type in chat.
Can someone check sound for me? Is the link in? Where's the link?
It's in general, yeah. Yeah, check my audio quality on Zoom. Check if you see this screen. It's good. Everything's good.
Yeah.
Awesome.
All right. You want me to get everyone started?
Dimitri. Okay, so we are live on Zoom.
All right. Welcome. How's it going, everyone? It's going good. Wow. Okay, everyone's engaged. How many of y'all came because I told you about it or someone told you about it today at the club fair? Hey, let's go. How many of y'all came because of the Discord? And how many of y'all came because someone told you robotics is cool and there's doing an event? Cool. All right. Well, this is the coolest club at York. You know, I'm just going to talk until Courtney gets his stuff sorted out. Fun stuff today. I don't know. We're going to talk a lot about the stuff I was going to talk about. We're going to start eventually. It's not over there.
I know.
So we're using Google Drive, so we're having technical issues. Okay. Supposed to be grand entry.
I know.
Is there someone in the call?
It's some.
Or on speed. All right, get some people.
Yeah,
all right. Hi to everyone on Zoom. We're gonna get started shortly. Bring it over here.
Oh shit.
Oh,
my function is.
there we go. There we go. Okay, everyone, please welcome the president himself, the man, the myth, the legend, Gordon Widow.
Okay. I'm gonna hold this to my face so everyone on Zoom can still hear me. I'm connected to my Bluetooth. There's a lot of people. Welcome everybody. This is our first general meeting for York University Robotics Society. Woo! It is the first time back in a long time. It's been a long time coming because, as everyone knows, COVID really shot us in the foot. But we are back and we are better, and we have all of you here with us today. I'm really glad. I'm really excited about the turnout. I hope we have half of you guys stay. Right? Just a little quick introduction to the team. I am Gordon Little. I am the president of the York University Robotics Society. This is Love Jivan. He is our VP of Events and Outreach. Curtis is our SumoBot team lead. I see our treasurer in the back, right there, Mike Omar. Right? And they are our executives. We also have our assistant SumoBot lead. This is Aldrin. We have our science lead, Adriana. Anastasia, our mechanical lead. Dimitri, our electrical lead. Oh, I didn't see you guys here. Our software lead right there hiding. I don't look you. Okay. All right, so I love the vibe. Let's go. Okay, so as I said, first general meeting 2022. Welcome. So everyone's like, how do I get involved with YURS? Now, I'm gonna say this, and I'm gonna say it 50 times. Join the Discord. Everyone comes in the Discord and say, okay, how do I join? Everyone asks me, join the Discord. This is very important, right? Has anyone ever heard of Slack? Right? How many people have used Slack? Okay, how many people know Slack is trash? Okay, Discord is better than Slack, and we need to keep our work organized. We have to keep everything compartmentalized so we can actually work together. There's a lot we want to do this year. So Discord is going to be our main mode of communication throughout. When you join the Discord, easy. Go to our website, YURS.com, hit that join button, takes you straight there. Immediate invite, right?
You're gonna have to be a little louder, by the way.
Is there?
People can't hear the back.
Can anyone hear me back there? You guys hear me cool? Okay, you're
I'm working on it. We're working on it.
All right. So when you join our Discord, and I'm going to reiterate this a lot because this is so big because everyone asks, how do I get involved? How do I get involved? Join the Discord. When you join the Discord, verify the rules, accept all that, and select the roles you're interested in. I hate pinging at everyone. I absolutely hate it. I'm sure if you're in a bunch of other Discords, you hate it too. Pings all the damn time. We don't do that here. We want to make sure you have the right roles so when we ping software, mechanical, whatever, the necessary people see the right stuff. Cool? So get your role, all right? And then when you're done all that, we do have a membership form in the rules and roles section. That's for this year. Just kindly fill that out. So when the year is done, we can show York, say, hey, these guys were in our club. We have this many members. You know, we are a big club. We need more monies, please. You know, things like that. So once all that is taken care of, talk to your leads, right? That's how we get involved here. I'll get into the different sections of the club shortly, but the best way to get involved is to talk to your leads, find out what you got to do to get involved, what are the starting blocks for you, what are the little things, and take it from there. All right. I see a question in the chat. Oh, okay, sure. All right, the camera is now on for those on Zoom. It's just my laptop camera. I don't know if it'll be beneficial. So yeah. So what is YURS? York Robotics Society. There's a lot of shamamble here, but to give you the long story short, we are a competitive robotics club. That's what we are. We compete in different competitions for different things at different times throughout the year, right? We are formally known as the York University Rover team because we started with Rover, but now under our belt we have SumoBot, and technically we can start more robotics teams. So if you guys want to start a drone team or a submarine robotics team, we can technically do that according to our constitution, but we need money. So we'll figure that out. All right. So for some background, we actually just came back from Alberta. Some of you might have seen that on our Instagram. Oh, follow us on our socials. Our socials are at YURS. We're YURS. We're on Instagram, we're on Twitter, we're on LinkedIn, whatever fancies your boat. If you're on LinkedIn, feel free to add yourself as a member, whatever. Looks good on your resume. Right, so as I was saying, we actually just came back from Alberta. We placed 4th in the Canadian International Rover Challenge. That means we beat every other Canadian team except University of British Columbia. So we beat UFT. Yeah, but a huge budget at that, right? So York University Robotics, we're actually a fairly successful club. It's just that we've been COVID really. Waterloo was not there this time. They weren't there, in fairness. But McGill was there. My master was there, right? But I digress. Now, as I was saying, YURS is actually a relatively successful club. We've actually won quite a few competitions in the past, from 2008, 2009, 2011, 2012, 2019, came like second in the science challenge. So we actually have a bit of a pedigree and a bit of a history. So we want to continue that and actually like push forward to do even better. If you actually go into Stacy Library, you'll see one of the winning rovers in the glass container. That was the one that won the 2009 University Rover Challenge. So yeah, our motto, very important. I guess it's at the bottom, so I don't know if everyone can see it, but our motto is learn, build, compete. What does that mean? Our primary objective here at YURS is to learn. That is what we pitch to Lausanne. That is what we pitch to our members. That's what we pitch to our sponsors. We are here to learn. At the end of the day, we are all doing various courseworks in STEM, in business, in whatever, and we don't necessarily always have the output to apply it. Competitive robotics is so interdisciplinary that we can take various roles, various majors, and put them into one big thing so that we actually apply the skills that we want to learn new skills, and nurture them, right? So we learn, and we take what we've learned, and we build something. Building something is how you really feel what you learn, like, for lack of a better word. Like, I can learn how to code in Python, whatever, like 2 input statements, but how do I know how to use an API? How do I apply this to my job? Whatever, what do we do? How do I design something in SolidWorks and actually build it, right? These are the things that we do. We build it out, right? And then we take what we built and we compete with it. Will it fail? Will it do well? We don't know. We'll try. That's the whole point. That's why we're here. So some additional things. So yeah, we actually started in 2007. As I said before, we're actually a fairly old club and a fairly successful club. And in 2013, that's when we changed our name from YURT to York University Robotics Society. So we have, as I said, 2 main teams, Rover Team and SumoBot, right? Rover Team is, for those of you who are new here and haven't seen all the other things we've been posting, one massive interdisciplinary project. It encompasses various aspects, including science, software, mechanics, and electronics. SumoBot is a more beginner-friendly option for those of you who are completely new. You might want to start there, so you can learn about what's CAD modeling, what are circuits, how to do your first program. We try our best to walk everyone through it, and we have our leaders to help you with that. So, what is our structure? My goal for this year, I want York University Robotics Society to actually have competitive elections. Anyone here, well, provided hopefully you're competent, anyone here can run for election position, right? However, some of these roles are selected based on what executive council may feel best versus an election. So our executive council includes our president, our treasurer, where's she? Our VP sponsors some fundraising, who is actually doing some network right now. He's trying to get some money for this year. Our VP events here. Our Rover Team lead, he's in a class, he'll be here at 5:30. Henry. Our SumoBot lead, Curtis. And a chief returning officer is just the person who's in charge of the elections. We assign that at the end of the year. So that's our executive council, right? Then we have our junior execs. Our junior execs are basically an extension of the executive council in order for us to help run this club. Because as you can see, there are a lot of you here. So this club actually needs a little bit of actual structure to get things done. We have a secretarial director. Right now, we do not have one. For this year, we won't select one unless it becomes absolutely necessary. A creative director and social media director. One person has both these roles right now. Harja, is Harja here? No, he's probably in the class. We're currently hiring for logistics director and accounting director. If you've seen our Instagram or some posters or even on the Discord, there is an application for these 2 roles right now. So if you're interested, especially for accounting director, these kind of roles are specifically where we try to make it more inclusive of other non-STEM majors as well. So we want to have everyone work with us. So these 2 roles, we're hiring for them right now, especially for this year. And then Rover has its own internal structure. We have mechanical leads, software leads, science leads, and electrical leads. Okay. One thing I want to point out. So one thing we try to do here at YURS as well is we try not to be too top heavy. A lot of clubs and a lot of organizations have way too many execs and way too many people trying to do too many things at the same time. Our focus, as I said before, is for us to learn. We want everyone to be more involved with the actual competition rovers, the competition robots, or maybe a part of the committee to help different things. But we try to not necessarily have too many execs. But I hope to see people here run for elections next time. So I'm going to hand it over to Curtis, because now we're going to talk about sumo bots. All right, Curtis, you might want to hold this.
All right, why is that the mic to that?
Yeah.
Great, awesome. Hello, everyone. I'm Curtis. It's amazing that we had such a turnout today. So I would like to begin to explain to you what Sumo Bots is. The reason why we're starting with Sumo Bots is it's the foundation to the York University Robotics Society. The reason it's the foundation, it's beginner friendly. So, for example, for those that were at the meeting today, thank you. I took them step by step. We held each other's hand as a team to start to build a 3D print, okay? And that 3D print is going to be the base for their sumo bots, okay? So, sumo bots. It's a small little robot such as this that goes head to head in a circle, and we compete for victory. Okay, we're gonna have a competition. Okay, I don't know which side you're on. Okay, so here's an example of a sumo bot, a small little cute bot. It's very simple to build. It gets a little bit of everything. Okay, we got a little bit of electrical, as you can see, wires and stuff, software, programming the Arduino, and of course, mechanical for making the sumo bot itself. Okay, so what is sumo bots? Like I said, it's the fighting of two cute little bots. I'm your lead with assistance from Aldrin over there. Okay, let's go on to the next slide now. Okay, be louder.
A lot louder. A lot louder.
Okay, great. The next sumo bot structure. Okay, so we'll be holding easy to follow meetings in person at Bethune. For now, it's Jack's, which is 125. I'll be there. Aldrin will also be there. And they're from 4 to 6 on Tuesday. Okay? So I think I said that already.
Is that Bethune?
Yeah, Bethune Jack's.
In the basement.
It's in the basement. It's beside, so it's the boarding room beside the cool room. So right after, if you guys want to go play foosball, pool, whatever, it's right next door. Okay, so the kits will be provided
As a loan.
as a loan. So the key here is that you're actually showing interest. You show up, right? And you actually have created a 3D model that's able to print. And with your 3D printed model, the physical part, I will give you a kit that we will continue to process you towards your end result.
As best as we can. We're buying more.
So we still got enough for as many people for today. Finally, what we're going to be working on is we'll be working on cool things like soldering, 3D design, and Tinkercad is what we're using. Basic programming skills. And for those of you that are in engineering, we're going to get you a head start in 1800 and 1801. We'll be creating control circuits, okay? What else should I say? It's simple tutorials, very basic. The reason why it's better than YouTube is because you're in person and you can ask questions. Okay, lots of room for creativity. We're gonna add little ears to our bots because I have a feeling that someone thought of that. And yeah, that's basically all for Sumo Bots. Thank you for attending.
Oh, competitions.
Who's next? Oh, competitions?
Yeah.
Oh, the competition that we'll be having will be here at York University towards the end of the second semester. In addition, we'll be traveling to McMaster University, who has their own Sumo Bot club, which we'll be going head to head against as well. Okay. Handing it off to
Love you, man.
Love Javan,
Oh, me stuff. Okay.
the second beautiful people.
Where is I don't know where you went. Oh, he's doing something. So I'll just take over for the moment. So outreach. How we work is that
All right, I'm here.
you're here? Okay.
All right, what's up, everyone? In the back, can you hear me? Awesome, okay. All right, I'm supposed to talk into this headphone. So outreach, I'm your vice president of events and outreach, which basically means I'm responsible for any events and any community outreach. Now, when I say community outreach, that could mean an event here at York, it could mean a community event, or it could mean a competition and an international event. So here's what we've done previously. Here's what we're doing right now. Here's the goal. So our goal is to promote STEM learning for students. Pretty straightforward, right? Robotics is STEM. It encompasses all fields of STEM. And we want to promote that to students and allow them to grow on their skills and learn new things. Next, we want to speak about robotics and its applications because that's a wire. Because practically speaking, if you're building a rover, well, what the heck does it do? You can send a rover to Mars. You can use robots in car factories. You can use robots to automate the world. It's really cool stuff. And we're setting you up to learn about the applications of robotics and STEM in the future. It's a crazy industry and it's an ever quickly growing industry. Next, we want to engage you with non-STEM fields. As you know, the Executive Council primarily consists of individuals that have a hands-off approach to STEM. Now, in my case, I am focusing on all the event planning, all the outreach that we do, which means I work closely with students that may not be a STEM major. I may be working with accounting students. I may be working with students that are engaged in the finance industry. I may be engaging with students that are in a social science industry, students that are actively engaged to create events or to promote things in the community. I've got all types of students that work with me. And that's what we want to do. We want to engage students that may not be in the STEM industry. I could grab a political science student and be like, hey, can you please help me do some public advertising or public speaking? It works and it's all co-production for everyone together. We need to engage everyone because if you just get all the STEM people, well, then you're going to lose out on the non-STEM majors. And the non-STEM majors have a lot of value as well, equal, if not more. It really depends on the industry. Now, past engagement. Here's where I'm going to talk about some of the cool stuff we've done. So we've done donut fundraisers in the past. It's been a tradition. Now we're also doing one on Friday. So if you want to buy some Krispy Kreme donuts for a really good price, drop by at Central Square. What are the timings?
All day, 10 to 4.
10 to 4, all day, business hours in Central Square. We're going to be selling some Krispy Kreme donuts. You can buy a box for $10. Kind of cool stuff. We've done bake sales. Jasmine here, she's our former science lead, very smart student, now studying to be a doctor. She was our science lead. She focused on helping us gain funds through her personal connections, which included selling donuts and cookies and stuff at her high school. Food and clothes drives. That's my specialty. There's a picture here. This was me in Calgary. I showed up about a week before the competition to do YURS events and competition event stuff there. So this was a local food and clothes drive that was created by an individual to help the community. We here at YURS really value working together with the community. I've said it before, working together to move everyone forward, right? And it's important to ensure that everyone that may not have the opportunities gets the opportunities. That's why we have industries that support people in our world, right? That's why we have Sumabot. It allows students that may not have the understanding to get involved. Similarly, I've done work to help communities that require it or that may not be as fortunate. Food and clothes drive is an excellent example of what we've done. Lasan video shoots. Well, Lasan likes robots and they like to show off cool stuff. So we help to make videos with our robots. It's really cool stuff. It makes you feel cool. And it's like you're an actor.
That's why the rover has a smiley face right now.
Yeah, that's why it looks like a Joker. It looked like a Joker at some point. We painted it to look more Christmassy. STEM and radio events. So I am a big guy for going in front of a camera and talking to people about cool stuff. There was a picture at some point here about me talking to a radio station about the growth of STEM and how it's applicable to our generation and the future. It's important to understand the value of STEM. That's why I actively work to participate in the community to promote STEM to the community and to our partners and sponsors because they see the value in it. There's a reason companies sponsor STEM people. They see the value in it. We want to show them the value in it and bring it all to their attention. Team meet and greets. How many of you guys showed up to our lovely cleanup event? One. Hey, we have a good group of people. Donate on the cleanup.
Yeah.
Cleanup there. Yeah, so we got team meeting greets and we're gonna have a lot more of these. We're planning to have weekly or bi-weekly meetings eventually. We're gonna sort out the details. Keep checking the Discord and stay in the put for that. But yeah, meet and greets are a great way to get to know people and what they're doing. It's really cool. If I told you Corden right here works for the city, you wouldn't believe me. But that's what Corden does. You get to know people at a personal level. If I tell you Curtis is a really cool guy and he works for Dell Technologies and he's done cool stuff for them, you wouldn't know. He used to work for Dell Technologies. But that's the point, right? You don't know someone until you get to know them. Here we're in a club-y relationship.
A society.
A society, right? But we want to create a relationship like a society where we're all working together and knowing people together. So eventually, if you come to our team meet and greets, it'll be awesome because you'll get to know the people you're working with, understand their personal relationships with you, and understand what they know. It's really cool to figure out what your colleagues know, and sometimes it might just lead to a trail or two. And robotics competitions. Yeah, that's the main premise. Compete, because when you build a robot, it's cool. But what is it going to do? It's going to service the industry. It's going to show people what robots can do, or it can compete. We try to focus on the last one, which is competition. We want your hard work to pay off. In SumoBot, you get to compete against other universities in Ontario and battle for the duels. In the Rover team, you get to fight and compete against some of the largest teams, some of the best teams in the world. We literally went against some of the largest US teams. They were good, but we were really good as well. We got to go against some of the top Canadian teams, McMaster, U of T, McGill. What did we end up doing? We destroyed them and left them in the dust. Again, we have to be graciously professional. So I will say we scored higher than them based on our competitive advantage, based on our strategy and their robotic design. But that's kind of it. You're competing, you get something out of it, and you get to enjoy when you're like, yeah, we're the second best team in Canada. Can you guys believe that for a minute? Second best team in Canada. Second best. Now, that also makes us the first losers, but that's besides the point. Now, if it's cooler, we're the fourth best team in the world. It was an international competition, which means teams from all over the world could have came. Could have came. And they did. Certainly they did. But we're the fourth best team. Now, with that, I'd also like to talk about the future of outreach. There's no slide. Is there a slide for outreach? No. Do you want me to just quickly talk about it? Like 5 seconds? Yes. Okay. I'll talk about the future of outreach as well. We're planning to do networking sessions, leadership workshops, meet and greets with other people from the industry. I plan to invite people from some of the largest tech companies in the world to sit down and have a workshop with you. Hey, how can I write a resume? How's your resume? Is it good? Is it bad? How's your resume? Is it good or bad? We're going to sit down with some of the top hiring managers from the country. And we're going to be like, hey, roast these resumes. But then also, what's the best way to write a resume? What do job employers look for? What's the hot words to put in your resume today? Everyone's trying to find a job. I guarantee you 90% of you want to work at Amazon, Google, Microsoft, all these big tech companies, right? Y'all want to see what's the best way to get in. We're going to have workshops and opportunities for you to join and learn about some of these opportunities. And then we're also going to get you guys engaged with the community as well through some of the various events that I'm plan with the local community, whether it's presenting to young people, getting them engaged with STEM. My marketing professor was telling us his 4-year-old is learning jiu-jitsu, and he's also learning programming. A 4-year-old learning programming.
That's OP.
Can you believe that? That's the next Bill Gates right there. That's the next Steve Jobs. A 4-year-old doing like basic Scratch programming. Yeah, it's Scratch, but come on, 4 years old, what were we doing? We were playing with like Blackberries and stuff, you know? Like, that's crazy. That's crazy. But yeah, we want to engage with the community. Again, use our use our society model and work with the community. Okay, that's enough for me. I'm going to pass it over to Corden to introduce the next person to talk about whatever they're talking about.
Awesome. Thank you, G-Man.
All right, before we get into over, I do want to add one more thing about outreach. So a big part of outreach is also working, as you said, with the community. We want to ensure that we show that we care. We want to get young kids involved. We might be working with KTY this year. We're trying to see something else. Some of you might know KTY. We spoke to them about it. We want to ensure that all these people around our communities see that we care. And it looks good for sponsors. So we get that out of the way.
We do actually care, by the way. I want to make
We care.
We care. But the sponsors also care.
Okay, so I will tell you guys about our Rover team. All right, who's excited for Rover? I know that's why like a lot of people are here. I want to hear about Rover. Some people are coming in just now, 5:30. Is Henry here yet? No, okay, that's fine. So, what is the Rover? Well, this thing right here, it's like this. Let's think about for a second. Let's see if we can get these guys to take a look at it. Very bad angle, but it's whatever. All right. So I'll tell you a little bit about. I like to call it all reliable. So this is our 2022 rover without the R.
You gotta be a little louder. There's more people joining us and it's.
Oh, those of you who are joining us, could you just move
Yeah,
closer to the back
please.
so you can actually see and hear me?
Yeah, come stand over
You
here.
just
It's
you
really
guys
hard
over
to
here.
find
Come
talk.
on in.
Yeah,
Let's
go
go.
on.
Let's take a break. Get on in there. Come on.
Yeah, join us.
Let's go. Let's go. Move it. I don't know if Zoom can see the rover so well.
Yeah, we could see it if you're wondering. It's right in front of, right behind you.
Is that Adam on the call?
Is it Adam?
That is Adam on the call.
is.
What's up, nerd?
Hi.
Adam Silverman is our former president. He is currently working in industry right now. He's, I guess, giving us a cameo. I
You see
don't
me,
know.
right?
Let's see if I can pull him up over here.
You wanna give him a cameo?
Can you even
Give
see
him a
me?
cameo.
Good.
There we go. Adam Silverman, everybody, former president of the YURS, who led us to fourth place position at CRC this year. All right, Adam. A little bit of a cameo. You have anything you want to add before we pull you back on the other side?
No, I think we're good.
Okay. All right.
You're quite the turnout. Good job.
All right. Where was that? Rover. Yes. So, Rover team. This is what I call all-reliable. The reason for that is that this chassis is one of the original chassis back from 2012. As I said to you guys before, COVID really knocked the wind out of our sails pretty hard. So our 2021 design, we kind of had to scrap it and iterate on this one. We were also short for cash, as you can see by the dollar amount of containers we use for electrical box. It's cost effective and it works. Right? So I'll tell you a little bit about this. As I said, an older design, but we took it, updated, much faster onboard computer, much more powerful motors and wheels. Our drive system is actually what got us through the competition. This current drive system, combined with some of the software, some of the software hacks that we kind of put together on the site there, actually got us through so much. Like a big shout out to our former software leaders. I don't think it's on Zoom for getting a lot of the work done. Shout out to our mech leads and everything. We worked really hard to get this thing done. So, before I get into Rover, were there any questions about some of the previous slides? Any immediate questions that you want to get out? Because Rover team, honestly, is quite a bit. No small about questions, outreach questions, executive council questions. You have any questions right there? Oh. So no, some of meetings did start last week, but catching up is essentially at your own pace because it's not. Oh, I'm so sorry. Yes.
Sumawai, if you missed a meeting, have no fear, because next week, everyone is not miles ahead of you. They are simply 2 steps ahead of you.
Curtis, you gotta be louder, bro. You're gonna be louder. Louder.
So if you missed the first meeting, don't worry. We have evaluated and been given feedback from the first meeting, and I took that into consideration with a slight restructuring to our meeting, and you are not far behind at all. I can catch you up in a moment. I can literally copy and paste what we have done to you, and I walk you, like, you literally follow exactly what I do, so you can't, and nothing will go wrong. Okay. Who's next? I want a big round of applause this time when I leave the stage.
All right. Now, okay, so back to what I was saying. Rover team. So Rover team is where it all started. We compete in several competitions. We've competed in University Rover Challenge, which is in Utah. We competed in the Canadian International Rover Challenge, which is in Alberta. We just came from that. We've also competed in Florida in the NASA Lunabot mining competition. We've also competed in the Canadian Science Innovation, something. And we've also competed in Ontario Rover Rally. So we've competed in quite a few competitions in the past. This year, we're focusing on 3/4 competitions.
Hey, we have a hot mic. You
Awesome.
want to use hot mic?
Yes.
Okay, all right, so let's hope it works. Or do the whole, or do the double flipping.
I'll put you over because Zoom's still in here. Okay, where was that? Okay. Woo! Mic check. Nice. All right. So as I was saying to everyone here, before. So close to my side. Too far?
Just don't breathe into it.
Don't read it now. Right. So as I was saying before, yeah, we went quiet for a second and everyone heard what you said.
Just keep working, keep working.
Right. You
No, just keep talking. Just keep doing your thing.
technical difficulties that there always be there, of course. Anyway, we're used to it. Rover.
Closer to your face. Closer to your face.
Give me a moment to breathe. So, Rover team. Those are the competitions we participated in before, and right now we're focusing on 4 main competitions. URC, that's the big boy. So the University Rover Challenge is an international, highly competitive challenge that takes place in Utah, the United States of America. More specifically in Huntsville, it's hosted by the Mars Society. It's Huntsville is home to their Mars Desert Research Center. Right. So Rovers are very happy. The other competition, well, URC is so difficult because, as I said before, we've actually won the first couple of iterations of URC back in 2009, back in 2011, back in 2012. I don't think we've entered URC since 2013. So our goal for this year, our big goal, is to make entries into the University Rover Challenge. Why this is so important and why this is such a big thing is that last year, for reference, 99 international teams applied to go to URC. Only the top 36 are selected. Last year, the only teams from Canada that got into URC were Ryerson and Queens.
It's TMU.
TMU, Ryerson, they're still called Ryerson, they haven't revamped yet. Right? So our goal for this year is to get into URC. Right? We're not going to be overly ambitious and say we want to win because it hasn't been a long time. And these teams are very, very, very competitive. Team that won URC for, well, I say last year was really in June, was University of Michigan. University of Michigan won URC and came to CERC and beat us up. So these teams are serious. So our goal for this year is to show them that we're serious too, and that we'll be entering that competition. All right? On a less more competitive note, we do have CERC again in 2023. CERC might also have a winter competition. We're not sure yet. They're still working out the details. And then the other competition we want to enter is a Kara Rover Rally. That's supposed to be a lot of fun. We've done one before, and we want to go again. The master did confirm it's happening this year, but we don't know when yet. So we get on that. But yeah, Rover team, here's a picture of our Rover doing the task that we performed the best at CERC. So the best task at CERC for us was a navigation task. Our Rover is like a freaking Jeep. It was like going over everything. Like, you see this incline? We were two-wheeling like 3/4 of the time throughout the entire competition. I kid you not. I'll show you pictures. Actually,
You know the Rover almost flipped like seven
if
times.
you go on Instagram, on our Instagram, check our reels. I don't know how many people have seen it. There's a video of the Rover moving at full tilt. All can flip over. I want to pull it up. See
Oh, don't worry, I'm gonna pull it up.
if you can pull it up. It's actually pretty hilarious. Let's see. Can we get that video?
Goddamn sign in. Which email is it?
Someone join the Zoom and share it on the screen. Yeah. But while we're working on that,
I'll do it.
yes, are you good? Right. While we're trying to get the funny video to show you guys, it's actually really hilarious. Are we sure they're there? Sure. Moving on. So, Rover competition and design needs. So, URC is, as I said before, extremely competitive. We actually have a timeline we need to do. URC has so many rules. Like I posted the rules in the Rover General chat for those who've seen it, those who have not. We need to, one, we have to like something like a Gantt chart of our plan. Like it's that serious. Like 1101 vibes, bro. Like seriously. We gotta give them a Gantt chart. We gotta show them our financial reports for the Rover because there's a cap limit of how much we can spend. We gotta show them what our plans are to get everything going. And at the beginning of March, we're gonna send them a video of how ready our rover is. That video is so important because that video and the report that goes along with that determines whether or not we get in. Our rover needs to be essentially complete by early February. That's the timeline we're working on for URC. It's short, it's stupid, but we're gonna try. Right? So on top of designing a whole new rover from scratch, we'll be upgrading this bad boy. This bad boy needs a new arm for sure, right? It's going to be our backup rover. If you can't hit the fan, for my language. It's also going to serve as our current rover rally competitive rover. We're still figuring out whether we want to do it exactly, but it's also going to be an opportunity for new people who might necessarily be ready to tackle the challenge of actually designing from the ground up to iterate on something that we already have. Right? It's a lot easier to see something and improve on it than conceptualize something from the ground up. So that's one of the main purposes of keeping this around. And as I said, there's so many different teams, so many people working with this rover as well. We want to use it for onto a rover rally, as I said, and possibly start winter if it does go through. For the ground up model, as I said before, URC, you want to go to URC. If you want to know just how competitive it is, Google 2020 or YouTube 2022 URC SAR videos and see all the, I think there's about 66 universities that's sending theirs on YouTube. So for you to actually view it and see how their systems look, what they did, all that. Okay, so after me talking for the past hour, I'll give this over to our electrical lead, Dimitri, who'll talk to you all about the electrical team. For those of you who are interested in electrical, he's your guy. Woo!
And the goal is just breathe heavily into the mic.
What's that?
All right, so ahead. Here is thinking of joining the electrical team. Hi, nice and high. Just want to see.
Who's interested in electrical?
Not bad.
Just making sure.
Not bad. Question. Okay, sure. Yes, you can. I was just you're jumping ahead here. Yeah. So, you guys can join one or many electrical teams. You can be on all three all three rover sub leads and single button. You can be on anything and everything you want. There's no restriction. The only restriction is your coursework, right? We're also in school, so it's up to you what you can and cannot handle, right? So my name is Dimitri. I am the electrical lead. A little bit about me, I guess, in the robotics here is that I only joined in March, right? And I've already gained so much more experience than I have throughout. So I'm going to third year. I'm in third year right now of electrical engineering, and I've learned like more from this club that I have in the past 2 years. Okay, and that just tells you something. Okay, and not just electrical, mechanical stuff. I learned what a M4 and M3 screws are. Well, you know that. But first, I never knew that before. I knew how to drill into a box here, so really exciting stuff. So what we do, everything electrical, anything and everything. So I made here a little block diagram. You guys can't really see the bottom there, but maybe go over there. Just kind of like how the rover works, in a simple way. You have software. We usually use a PS4 controller. Let's say you press the button on the PS4 controller, and then you send a signal to, a wireless signal to the onboard computer, which is called the Jetson MX computer. For those who are interested in that. And that's all software, pretty much. And then there's other aspects of stuff like GUIs and cameras, which are software that these will cover after this. And then after that, after it reaches the rover, then it reaches the microcontroller on board the rover that directly control the drive system or the arm system, right? The motors. And then we send electrical signal to the motors, the actuators, and then that actually moves the arm, which is all about the mechanical design of everything. So exactly what the bottom block diagram is. Perfect. So like, for example, I want to move my joystick to move the arm 20 degrees. And then that signal goes to the computer on board the rover. And then the electrical side is sending the signal to the DC motor or stepper motor or servo motor. And then it actually moves into the kind of request.
All right, so here are some tasks that you can expect to do and do on the electrical team. Is we cover the entirety of the electrical system, so battery management, ensuring all electrical components on the rover receive power. This guy right here is our power distribution board. So we have these we have 5 really powerful batteries that we took to Calgary with us, and we got stopped many times because they're quite dangerous. And they power the entire rover pretty much. And then we also have the electrical box, E-box, as we call it, which is this beauty right here, our $12 E-box, which I'll explain why that is so funny. And then there's so this year we're creating a whole new rover from scratch, and we might want to create a better E-box for this guy. So one task we look into that is just designing the box itself. So that it contain all the electrical components, and the main thing is that it has to be very accessible, right? If I need to access a particular part of the box, it has to be easy. Like the batteries here, they're all actually I'll do that later. But like if I need to take out the batteries, I need to be able to take it out like within like 30 seconds. Nice and easy, right? Just in case the battery fries out, we have to replace it. We can be able to do that on competition like that. And then we soldering. Right, soldering is really important. Everything here is soldering. The majority from March, this I joined in March, from March till August, the majority of my tasks were soldering. Okay, it's actually quite fun, especially when you get good at it. Remember my just a little small thing, but my first time I soldered, I tried to solder 6 wires. It took me about 5 hours. Now I can solder about 6 wires in like maybe like 30 minutes, right? And it's fun. Yes. All right, just some more tasks. If you think that was it, nope. We have embedded systems, right? This is not software. It's electrical programming microcontrollers. That's the electrical side of things. Yes, which is here we have the Arduino Uno. I'm sure most, if not all, everyone knows the Arduino software. Like Curtis talked about with the Sumo box. We last year here we used the TC controller, which is kind of similar, and then just programming it, right? We program in C. We don't really use the Arduino IDE that much. SumoBot does, though. Yeah, SumoBot does, but not the rover electrical team. And then last but not least, PCB design and layout. Design and creation of custom printable circuit boards. Now, this is a very limited task. There's not too many people that can be working on it. But if you're extremely passionate about it, and like let's say you want to do it as a career, just like myself, then let me know, and I'll try and prioritize. Which I'm jumping ahead, but I'll talk about that later. So last year, I already talked about our amazing e-box over here, and here's sorry for the poor quality of the photo, but here's our gripper PCB. That was one of the custom PCBs that we designed last year. And then this is a look into the e-box here. You can see kind of underneath all this mess, which again, hopefully this year won't be that messy, is a power distribution board. And here actually the Smart Max, which is just like a motor control for the drive system. And then the label that you can see here. Going back. No, sorry, 145. Here. All right, so this here, this is this photo here, this e-box here, as you can see, much more professionally done. Even though it kind of looks like a mess on the inside. But much more professionally done in the box itself. That's something we're going to be kind of aiming for. That is actually a QPC's e-box from the competition. I kind of just stole a photo of it. Yeah. And then this year we're looking on, doing a lot more critical circuit boards, PCBs, but again, not too many. And the main thing here is that, as I said before, last year we used TCs.
which you just plug into USB, just similar to like Arduino, and use it programming. This year we're actually gonna get our own microcontrollers, so like a chip. This is actually the exact same chip, but just not like an actual photo of it. And we're gonna put this guy on our custom PCBs, and we're gonna program it like that, so that everything's custom. I haven't really worked out how many of these I will need. If you're interested, let me know again, because we need some for the new rover as well as the old rover here. All right, so for you, new members, for you, this is why you guys came here today, is to learn about this. We are looking for people that are willing to learn and want a chance to use their academics practically. So show of hands, who here is not in Lasan? Too shy. Nice and high. All right, that does not matter here, okay? We will teach you everything you want and need to know for anything. All right, if you guys like rovers as a hobby, you came to the right place. If you want it as a career, you came to the right place, all right? We're just looking for the motivation. We want to see the drive in you that you hear. We will not be chasing you for tasks. You got to kind of have to chase us. Not so much chase, but like be aware. Yeah.
Can you repeat that louder, actually?
You can.
We will not be chasing you for tasks.
Yes, we don't. Thank you. We don't chase you to do tasks. You must chase us to do tasks. Look around you. All right. There's like maybe 40 people here. I don't know. There's at least 3. Very. Yeah. So not everybody, like, you guys kind of have to compete with each other, right? I'm not saying compete each other in terms of skill set. I've been saying compete with each other in terms of like asking for, give me something. I want something. If anyone here, I see some of my face, the people who talked to me at the club fair just now, I said the same thing to you. If you want a task, you have to come to us. We're not going to come to you. And like I said, you don't need an experience to join. We prioritize learning over anything else. And for onboarding, in terms of coming to the electrical team, we have tutorials on PCB design and layout. So even if you don't get a chance to do one for robotics, you can learn yourselves to do it in your own time. Soldering and embedded systems, you know how to program. You see what is embedded systems, right? A task will be given on members' preference and skill set, as well as desire. I put that there. And an actual onboarding document is actually finished, and it will be posted on the Discord and the rover electrical slide, and chat, and it will say exactly what I just said about tutorials, PCBs, and everything that you'll need to know to be joining us this year. Are there any questions about what I said or didn't say? That was the time for electrical.
Any questions for electrical? Oh, Zoom chat.
What? Any questions? Hands? Yes.
You designed the front heading of the dog.
Sorry?
You designed the front heading of the
Oh,
maybe.
that's actually an important question. Hold on.
Design what?
Good question.
So, I guess you're asking about communications. That's a very good question.
So we have routers.
Yeah.
That are bought already. This year, if we have the time and the capabilities, we are looking to create our own type of radio system. So instead of using store-bought, we want to create pretty much design an onboard radio for the rover. This is like, we already have something that works. So this is something extra that we're gonna hope to try and do.
So to add on to that, just to answer your question specifically, we use 900 megahertz routers right now. 900 megahertz.
Really good.
Each competition has very strict rules as it relates to your frequencies. Certain frequencies we actually have to get like a ham radio license for. So typically what we do is that we do low end frequency for less what's the word? Attenuation. Signal degradation, right? But this year we want to ensure that we have both reliable signal and increase in bandwidth. So we're not sure just yet. It's a part of the design phase.
We're not like the team that's gonna pull up and use Bluetooth.
No.
The team used Bluetooth and the rover just shut down when it got like 20 feet that way, and like that was
Our rovers actually have to operate like within like a kilometer. So
and that's to like work through like big jerk hills and stuff. Bluetooth is not optimal, so yeah, no Bluetooth.
Oh, there's a question that says, will the onboarding be updated and made more clear for electrical?
So there's
Yeah.
no electrical onboarding as of yet. I'm creating the first new one. You might be thinking of the onboarding for the software team. That I believe will be discussed on the software team there. But I believe it's gonna be updated for the team using it. But yeah, the electrical, it's only gonna be like maybe a one-page PDF of just links to tutorials and just some like description of the team, like yeah.
General question. Do we, you said we, do you want to take you for this? How do you want to be for email? You want to just like ping them in Discord?
Yeah, this,
Message?
all right, I'm gonna say this again. I said it at the beginning. Discord, like honest to God, like Discord is where everything happens, right? I'm gonna be cringes just to show you how important Discord is, right? If you go into our rover, everything is organized for you. You go on the side, rover general, electrical, whatever. You're in the rover electrical, you can talk amongst your electrical friends. You ping this guy at Dimitri 27 times, right?
Dimitri, electrical lead.
Yeah, electrical lead, yeah, for sure, right? But just what the point is, we have timelines to make, right? We want to give everyone the ability to have ownership of their tasks, but at the end of the day, we have to make our deadlines so that we can compete. We won't wait on anyone too long to hold up the entire project, right? It's like working for a company. You have your assignment, you're supposed to get it done. It's just that we're working for free, we're working for fun. So we're not paying you to do this. You do this of your own volition. So if you're not interested and you don't want to do the task and you're taking too long, right? If you're taking too long because you don't understand, that's different. You come to your leader and say, hey, I'm having a problem here. How can we work through it, right? Exactly. But if you're taking too long because you're saying, oh, I had basketball today and I couldn't be bothered, like, we don't care. We move on, simple. We have our own deadlines to meet, right? Yeah.
Yeah, just before I take any more questions, if there aren't any, as of now for the electrical team, and I'm pretty sure for most teams, and I think this will be reset later on. There are no tasks, so if you come to us after this meeting and you ping us, hey, I want to do something like right now. None of us really have anything to do. Give us like a week or two. I myself, for the electrical team, once I have a list of tasks to hand out, I will tell you in my in the chat.
Yeah.
On Discord, I have tasks that you guys want, who want something to do, and then at that point, you guys have to attack me. Okay, that's simple. Any more questions?
Any more electrical questions? Electrical team questions. Everybody good? We can move on. Okay, thank you, Dimitri. Wonderful electrical lead. All right. For those in Zoom, that's it for electrical questions. We are going to move on to our science team. So everyone give Adriana, our science team, a round of applause. All of our science.
Science team, it may not look too robust. We currently have no science on our presentation order, but to be fair, every don't really need to do the science. But so for every rover competition, there's always a scientific task because it's planetary science related. You want to send a rover to Mars, and on Mars currently the scientific community is looking for signs of life.
Louder.
All right. So in order to look for signs of life, we can't really send a human there as of yet. So we have to design a little bit capable of detecting that. And Caleb design is incredibly multidisciplinary. You need to design the mechanical system to collect the soil sample. You have to design electronics to control this. You have to design essentially a miniature robot to catch. And then on top of that, we have to autonomously study the soil sample to reach the correct size life. This could mean anything from spectroscopy to chemical testing, a wide variety of things. We currently don't have a full robust design, smart payload. So that's going to be a large part of when you really research and doing the designing portion of this payload. So you will search for signs of life. So that pretty much covers what this team's about. Individual tasks kind of be divided depending on what you're interested in doing. Anyone's welcome on the science team. Historically, it's been like 2 people trying to really pull it together. So we're hoping to have a little bit more this year. The payload is with most space missions, like the like shining stone of it, like returns the belly for a lot of for its mission, essentially. Refers to it like James Webb Space Telescope. The telescope is what it really cares about, things taking pictures and returning the pretty colors. That's essentially what we're working. The rover is vehicle carrying the payload. So we really need to get working on that. In terms of onboarding, I'm planning on hosting a sub-team meeting at some point in the later half of the next week. The exact date and time to find out if you're interested in joining the science sub-team. I will post a message in the Discord. With kind of a poll on what time, where I find time that works for everyone to join. We'll have it in person, but we'll also if you're interested and can make it on campus, will be pleased. And then also the meeting notes and dates time to depart for your that's pretty much covered.
All right, awesome. Thank you, Adriana. All right. So I'm going to reiterate some of what she said because I want to convey the magnitude of the importance of the science team because I really want to make sure everyone gets this. Science team, not because it says science, doesn't mean it's not important, right? All of this is 100 points at URC. Out of 500. For URC, for example, all our science experiments have to be done, as she said, on the rover. Meaning we're going to have to design actual chemical tests on the rover, actual ways to avoid soil contamination on the rover, and then afterwards take that data and write our own reports. I don't know if you guys realize the magnitude of what I just said to you, right? Some teams, the richer teams, actually have mass spectrometers on their rovers, right? So science is actually really important. If you're in a biology major or even a chem major and you're really interested in designing the chemical tests that we need to do in order to do the research for the soil analysis, for the life analysis, for all these things, please, 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 we need science people for our team. It's so important, right? Are there any questions for science? I'm gonna check the chat real quick.
Chat's fine.
Chat's fine on Zoom. Any questions for science? Okay. I'm gonna take it as a no. So Adriana, once again, thank you for coming. We are really, really appreciate you. If you're interested in science, check the science chat on Rover. If you watch the 2022 SAR videos, you'll see how some of the other teams did their science packs. They have special scoopers, they have special things. It's crazy. All right. We're going to move on to mechanical. And on mechanical lead, Anastasia, whatever you want. This is our mechanical lead. Our mechanical lead, Anastasia, also works in tandem with our previous rover lead and mechanical lead, Hisham. Hisham is actually currently in Alberta on a co-op, so he is remotely assisting us with designs. For now, I'll hand over to Anastasia, who will see some videos and stuff about mechanical. How many people here are interested in mechanical, by the way? Yeah. Oh, there's actually a lot of mechanical people here. Let's go. Okay, this is what you were waiting for. Here you go.
Okay, hello everyone. My name is Anastasia. You can call me like, I don't know, a lot of people struggle with my name, I guess. And something like that, yeah. So basically, this is the one sort 2022 that was actually on the competition this year, and that was from the 2021. You can see like actually this year we're planning to really work on the arm of the rover because we really want to change the design and make it more like personal, portable, not really heavy, as well as like that one was really overly engineered. They're like, yeah, we need like a much simpler version, but as well with the same functionality. So for example, this is like from Hisham. It was like joking that mechanical is not only about design or assembly. You as well need really to pick people in order to get many advices as you can and really to work with the team in order to get the best prototype possible. So yeah, the responsibilities of the mechanical team is like really conceptual design concepts and functional solutions, create appropriate CAD models, as well as like really consider the financial side of it. So you don't want to like make it like cost of 100K because we don't have like that budget. So your job as well as like mechanical team member is to see projects through. So I know that a lot of people have different like really experience and the background, but we don't really like, we're looking for everyone. For example, we also planning this year to do an assembly team. That's probably for first year students that don't really have experience. But it'll be like really good opportunity for you to get it and really to know the rover from the inside out. You also your job does not end in the CAD model, and you need to deliver parts whether you fabricate them yourself or send them over to the machine shop that we have in the basement of this building. So as well as you really will face a lot of failures, especially with the printed parts, they most of the time break. So the picture of the
Yeah, that, oh, so
yeah, this is the
one back, Hisham hit his head on the rover swing can, that's gonna have a helmet.
yeah, and this is Arian. He was
Former mech lead.
former
It's
wrestling.
on call right now.
Yeah. Some integrate different systems, so the end of the arm. And work with other teams to build full video printed parts for them.
Yeah, so example, this is a holder for our onboard computer. We'll get into software in a moment, but our onboard computer is a NVIDIA Jetson NX. It's based like a Raspberry Pi on steroids. So we have to design a 3D printed case for it. So yeah, example.
Yeah, we're also gonna like really need to consider a lot of factors when you're printing, like for example, like filament. Like because a lot of parts break, especially if you control the fill of the part, if it's like really low, they'll probably break. So we also face problems in that. So as well, work with other teams to test their electrical and software systems. We really closely work with electrical team. That's when we establish the this is Sean. It's remote, right? Like remote rover speed.
Remote rover lead.
Safety.
Yeah, safety is actually so important, not just to us, but also to York and to Lausanne. So we stress safety as best as we can. As you saw in an earlier picture, Hisham hit his head so many times that to get him a helmet. But generally speaking,
we want to comply with all safety rules in the shop, outside of the shop, but especially in the shop, okay?
Historically, no digits lost on the team.
Yeah, I don't remember what voltage this was at, but the guy just been like stupid fast. It was fun.
So basically, these are like pictures of our Henry, like the rubber lead, and
Yeah.
Hisham working remotely right now for the new rover that is going to be completely redesigned from scratch. That's the parts that they're working right now. You left for the slides. So yeah, basically, what we got, as we was told probably before you guys heard, we're gonna have two different rovers. The one that you see right now is gonna be redesigned in terms of like the arm. Is gonna be our main focus on that, and we're gonna build as well as another rover completely from scratch. The slide that you see before and the pictures in it was from for the new rover, and in terms of the written and end effective design, we're looking for people as well that gonna really take a part as a lead in terms of that specific part of the rover, which is written and end effector. So this person will decide which joint and end effector requirements based on construction tasks. For example, you're seeing the 2023 model. Researches possible designs, evaluates multiple designs options based on robustness, feasibility, and other factors. Prototypes their designs in parallel with other subsystems and by timeline. So as a state of the art metal components such as bearings, motors, etc., alongside with your motor parts. As well as we're looking for the lead for science of assembly design, because we also working really closely with science team in terms of the design, for example, like the soil test and stuff, all of that. So the person like analyzes science requirements from condition documentation and translates to mechanical requirements. Your investment in the science team. Prototype design in parallel with other subsystems using 3D printing as a start, but deciding on final materials. Documents vigorously findings since this is historically a weak point for our team, and other responsibilities as they arise.
Right. I just want to touch on real quick that again, the science component of URC especially is critical. As I said to you guys, so all the teams will have to be working together. It's already interdisciplinary, but that is actually its own like kind of bubble for the competition. A lot of teams fall down there. At CERC, it was actually one of our strongest points, right, for science, because our previous science team also really wanted to report. So it's very important, guys. So if you're interested in science, again, talk to Adriana.
Okay, so we're also looking for CNC specialists. We have like in our actually room the CNC machine. Basically responsible for upkeep of our mini computer as chemical control, which is downstairs in our learning room. Verification parts of the needed include setting up workpiece tools and basically the whole process. Communicates with shop machinists on a regular basis to establish best practices. Yes, should be a general point of contact with any questions or concerns regarding how the design for manufacturability. Because like this machine that we have like in the basement, no one knows what to do with it.
So no, Henry knows how to do it.
Okay, Henry stuff.
All right. So for reference, we actually recently got a small CNC machine from LES. Shout out to LES for the sponsorship. We will be doing some small CNC work in-house as best as we can. So we'll be working towards getting that set up. For reference, we do have two sponsors on board, the competition sponsor and the local sponsor who will be doing some metal fabrication for us. So there will be instances where you might have to interface with someone on the outside of Lassonde or outside of York to say, hey, that's actually the professional world now. You're saying, hey, I have this design. How can we design for manufacture? How can we do this? Are you able to do this? What are the costs? What are the constraints, etc. So a big part of our teams is also interfacing with outside people, especially our sponsors, as we get them on board.
And as well as we're looking for assembly and function specialists, basically making pictures for presentation for mission sites, making pictures for testing and coordinator. These are assemblies for designers, drawings, and specifications, because documentation, scaling, assembly procedure. optimizes procedure for world-class results, prepares system, toolkits for challenge.
Yeah, so, oh, sorry.
Yeah.
So I'm gonna touch big on this too. So again, mechanical, we spent over the summer almost every night downstairs there working on this guy. Partly because, you know, we were last minute, but also partly because there are other little things to do. Like mechanical actually has so much work to do. Well, maybe not this time because we're doing a lot more CNC, but on this software specifically, it's based on a lot of drilling, a lot of bolts, and a lot of nuts and screws, right? So we can't just design. Mechanical engineers need to actually build things from time to time with their hands, right? So there will be occasions where you guys have to take time out to assemble things together. It's not just design, right? We have to put it together eventually. Right.
So yeah, basically to sum up, like looking for like probably info where to start. If you haven't done CAD modeling before, basically 2D design. I would say my personal advice is probably start from Fusion 360 because it's like interface friendly and like it's just easier to use. If you're familiar with that, SolidWorks is the king for CAD modeling. As well as where can you get like all that info? LinkedIn Learning, it's free for all uni students. And you can get some lessons from there in order to get like, I guess, the basic understanding of CAD modeling. As well as it is a good thing to have a like machine training certificate. It is actually really easy to get. We have it downstairs. It is every Tuesday, I believe.
Yeah, the booking for the machine shop training is actually fairly tricky. My advice is get your WMS done, get your machine shop training E-class done, and then try and sneak in.
Yeah.
Yeah.
I believe it is from 9 to 12.
I think it's like,
yeah.
it's at
Every
very
Tuesday.
weird times, yeah.
But yeah,
That's it?
Yeah.
All right, so thank you, Anastasia. Anna, our beloved.
Okay, so we've been at this for a while. I know it's been a while. Thank you, everyone who's been with us so long. I'm so glad to be here after an hour and 20 minutes. Fun fact, we do have snacks and drinks afterwards. So there is something to look forward to at the end of the tunnel. Right? So now I'm going to hand over to our software lead. For those of you guys who are interested in software here. All right. Okay, so for software, I guess you can say the other team is back killing me for this, but save the best for last. Are you gonna kill me? All right. So we have software. I'm gonna invite Karen Street and Joaquin to come up and talk about it. Let's go! Woo! You might not want to stand in front of the slides. You're in front of the screen. You're in front of the slides. Go in the middle. Just you. Yeah. No, that's my chicken. There you go. Still okay. Be louder, bro. You got this. Use your outside voice.
Hello.
Louder.
Louder, Joaquin, louder. We can't hear you.
So we're basically starting everything from scratch. All of this local everything. All of the one microphone is down. Oh, as my partner said, I was trying the entire code base.
NVIDIA Jetson.
in like video jets and and we're gonna be doing that. We're gonna be replacing it with probably around 45, and essentially we're gonna be rewriting on the previous ROS to the updated version. Specifically, we're gonna be using
Just record before I don't. We'll see if you can do the box.
Based on what you're organizing. Mainly for the research that we can include. Basically, we divided up the top two systems. The top two are two bunch of systems, and we're gonna have our members that are not leaders, right? We're gonna have them actually lead their each like system. So each system is gonna have their individual lead, and so that way you'll be engaging in leadership and you'll be collaborating with each other, and you'll have like a more of a sense of responsibility. So do you want to just like really quickly go through the systems? All right, so there's the camera system, which is essentially just kind of the camera setup. Like
Yeah.
There's a bunch of camera systems. This one,
Yeah.
just give you like one link.
Actually, a quick tangent on that for you guys. Fun fact. So, for this rover's camera system over CERT, we spent a lot of time. We spent a lot of time in order to get something called hardware encoding working on that camera, right? Our onboard computer actually has the capacity to do onboard hardware encoding. So it saved us a lot of latency in order to get that running. Like our previous software lead was on the fly working on it to Alberta to get it running. And without that, we would have not come forth. So camera system latency is super important.
All right, next is the communication system. So I believe this is essentially how we're going to be interacting with our members. Not control system. The control system down there is actually controlling our rover. So the previous rover is actually controlling the export system. And our new rover is inside the rover.
Use VR.
VR? Yeah, I know all that. Okay. So for computer vision, we're working with the library called CD, and essentially it's allowing us to incorporate usage and other like fancy AI capabilities. And it allows us to also to a certain degree do object recognition or autonomous driving. There's going to be a lot of collaboration and actually comes to like the team leads for each software subsection.
We finished it. Sure. Health system. All right, the health system is literally just like oh yeah, making sure all the parts are functioning. Like so. It's literally health systems. It makes sure the computer doesn't blow up. It uses temperature sensors and that sort of stuff.
And the powers to like being received as required. Here's the logging system, which essentially takes care of like electrical logging.
Yeah. So we need to ensure that for our batteries that we don't pass a certain current limit, and this is part of the communications and the collaboration between teams. So electrical will talk to software, and software will talk to electrical. Say, okay, what help systems for the electrical components that we need to have on board, and they put it in.
So the I can't pronounce that word. The odometry. Odometry system. I got it. Yeah, first try. Essentially, that's our GPS system. So that's going to allow us to determine our location and essentially, it's gonna be working along with autonomous driving system, which is a big boy over here. And also, it's gonna basically almost incorporate autonomous driving for URC that's coming up.
Yeah, so big tangent on that. Again, the word URC has been said a lot today. I can't stress it enough. URC is uber competitive. Our rover needs to be done by like January, early February, right? And for one of the tasks, you have to have autonomous driving on everything autonomously to do that task. 100 points right there. Okay, so we have to have that ready.
Yeah, so just talking again about autonomous driving.
I told you.
And there's a whole mission. So we're gonna have to do something this way. Autonomous mission. And we're basically self-driving. Charged fields. And they're gonna have to work all that. That's pretty. That's surprising. I'm still here.
So I was like,
Does anyone here right now have any questions? Yes, that's the way. All right, perfect.
yes.
Yes. Yeah.
Yes. So fun facts. You can be a part of more than one team depending on your own personal bandwidth. You are the one who can discern whether or not you have the bandwidth to do more than one team or more than one task. I have no idea what your personal schedule is, what your course load is. Only you can make the decision. However, you can't make the decision at the detriment to yourself or to the club. If you are interested in more than one thing, that is fine, but try not to overburden yourself, okay? Yeah.
Do you have another question? That's all right. Like changes happen, you can switch teams whenever. That's okay, as long as just try to be active and try to communicate.
Yeah. The only problem comes if you feel as if you're assigned a task and your task is being affected negatively. Then you need to speak to a lead and say, hey, I need help, or hey, can you assign this to someone else? But usually asking for help goes a long way. Ask for help.
Any more questions? Did you have one?
Yeah, I was responding. Are you okay?
Yeah. I'm all right.
There's clearly nothing wrong.
He's fine. You know, he's a resident punching bag. I'm lying, but but no, he's fine. Tell him. Any other software team questions? Let's go.
So yeah, we'll be using data operating system 2. Which you said the first one. Yes, so there are a lot of distributions. One we're going to be using, we specified this at the start. I kind of forgot.
There's the one that's due for 2027.
It's the turtle one. It expires
2027.
yeah, 2027.
So to answer your question,
The turtle one.
our current rover over here is operating on ROS 1. We might be migrating this to ROS 2 as well. I'm not sure. We're still, yeah, but okay. The new rover will be ROS 2. Let's stick with that, right?
We did mention we're gonna use the ROS 1 for the new one.
Yeah, because that one's on ROS. Yeah. So ROS 1 has a lot of things. If you already started learning ROS 1, great, because obviously ROS 2 builds on the foundation of ROS 1. If you haven't started learning ROS at all, you can look at ROS 2 documentation, but it does help to understand how ROS 1 works, to understand why ROS 2 is better and why we're using it and what features of ROS 2 we'll be using, because a lot of libraries have not moved from ROS 1 to ROS 2 as yet, but there is a bridge available to use. Okay. Any other software questions? Oh, okay, let's do this guy first. Yeah. Yeah, so ROS is Robot Operating System. It is essentially a container slash API slash, it's a one big thing that runs on top of your system that allows you to put different topics and different subsystems together. So it uses Python, C++, and I think even a little bit of C, depending on what library and API you're using.
Also, just to like really quickly elaborate on that question you answered there, the distribution is Humble Hawksville.
Oh, for us too? Okay.
For us too, yes.
Okay. Yeah.
Talking about entropy, right? In general, like we have all
For the most part.
I'm assuming everyone here has the access to PC that's
Okay. Yeah, sorry, you had your hand up for a while. You need help? So communication is key, right? If you are unsure about a task or if you're running late or whatever, ask for help. That's what it really boils down to. Ask for help. Hands again. I know I saw your hand up, so I want to let you get the chance to ask your question.
The visualization system, what? Computer vision and visualization system. Okay, so wait, is there computer vision?
No, other slide.
Oh, okay, yeah. So computer vision is more like actual like markers and stuff. So it's like placing markers, like 3D markers. It's a lot about mapping out like the surrounding environments. And the visualization system itself is more to do with the actual camera and the configuration of it.
Yeah, so it's so the computer vision is typically is more so to do with how we're taking in information for autonomous driving and autonomous detection. Visualization is by itself a kind of tangent to computer vision to see what is our actual surroundings and how does that work in terms of avoidance and stuff like that. So they're separate but similar.
So basically, the computer vision system is a higher level. So visualization system is based on computer vision system.
Continue questions. I know there's a lot of questions, so like we're trying to like kind of go through them quickly. Raise your hand up high so I can see who's asking questions. Let's do that. No, that's fine. Don't worry about it. Don't leave it. Don't worry about it. That's fine. Don't worry.
If you can reach out for help, that's definitely always an option. If you feel like it's a task you can't do without it, always again just communication. It's all the
And then like questions of yeah. Okay. All right. Any more questions? Because we want to wrap up soon. So any last questions for software? Wow. Okay. All right. So in the efforts of wrapping up, thank you for our software questions. We have 2 more slides. So why be involved in YURS? Thank you very much. I am happy to tell you that 1, it's fun. It's actually fun. I'm not kidding. Like, going to competitions, talking with your friends, working on something, failing, doing it again. It's actually fun. 2, learn new things, you meet new people, you apply what you learn, and it's a massive, massive resume booster. I'm gonna say it again. It's a resume booster. So join YURS if you want to boost your resume. Unironically, again, makers, we actually have people who use YURS to further their careers. People who have gotten jobs at Amazon Robotics, IBM, Cadence, Geotab, Semantic Health, Autodesk, NASDAQ, RBC, Kindred AI, CS Space Agency. Working in this club gives you the resume booster you might need to get that call, to get that job. So I highly encourage you to be able to take ownership of tasks. So when you get into that interview, you can say, hey, I did this, right? You work on a team. Personal projects go a long way, but team competition projects go even further. Okay. Our last slide. So what are some membership benefits? So this year, we are doing a resume tool. What does that mean? So a lot of our sponsors are interested in college students or career students. So for those of you who are actually continuously putting in work and tasks, we will get your resume added to our resume pool. So as we get our sponsors on board and they ask for that, we also can say, hey, here's a resume pool, pick the student you want, you get in contact with them. Members, so not everyone will get the chance to use certain things, right? We have a CNC, but a lot of our equipment is expensive, and we want to ensure that people are serious and not playing around with them. So sometimes for certain things, we'll be a little bit selective who will get the chance to work with it, but consistent members people get the chance to operate. So for example, our onboard computer, very expensive. Not everyone will get a chance to direct compute a lot more simulations, but for those who do, get a chance to maybe assistant. And competition. So as I indicated before, we have competition in Alberta. We're trying to go to Utah this year. Not everyone will get a chance to go to competition. The number of people who take the competition is going to be solely dependent on our budget, how much Daddy Lassan is willing to give us, how much we have in our piggy bank, and who is the most consistent and thoughtful and useful person in that competition.
Stop breathing into the mic. You're killing everyone.
I'm killing everyone. I'm sorry. I've been talking all day. It's a long day. But yeah, those are your membership benefits. And just to go back, these will be yours. So thank you everyone for coming. Thank you all meeting. Let's stop. Let's get. Let's get everyone some food in our system. Thank you all for coming. Appreciate it. If you have any questions, reach out here. Yeah. Follow us on social media. Discord. Make sure you get your goals done correctly. Make sure you build the membership card. All of that. Can we get a snacks out here, please? And thank you. Snack.
How do you fucking jump? You don't see Gordon jumping all the time.
Also for those in Zoom, thank you for joining us. Are there any questions on Zoom? I do wear almost like all right. Thank you those in Zoom for coming. I'm here looking at chat. If you have any more questions, I'll be closing the Zoom shortly. Yeah, I'm glad the Zoom seemed to have worked out. I did record it, so I'll see all that.
The mic for the computer.
Oh, of course I have it. Hey everyone.
Good job.
Yeah, thank you too. Anyone else, any more questions? If that's all for questions in Zoom, then I'm gonna close it out. Thank you everyone for coming. YURS, peace.